Are we recording? Yeah, there we go. All right, so here's our first graph. This is one of your parent functions. It's called the square root function. And this is what the square root function looks like. Okay, and you can put a little arrow on the end of that line here, like this. Goes, oops. Doesn't stop there. It's just that this is what our graphs did. Okay, so let's define the domain and the range of the function g. So what's the domain of this function right here? Can someone tell me from looking at the graph? Tiffany? Yep, to positive infinity, right. And what's the range of this function? What's the range? Same, right. Starts at 0, that's your smallest value, and it continues on to infinity. Okay, so I think by now we have domain and range down, which is a good thing to have down, right, when we're studying functions. Okay, so here's our first transformation. Now we're looking at, and if you wanted to, you could call this, you could call it y, or you could call it something like this, j of x. You could give it a brand new name, a brand new function name. G is being transformed to j. How is it being transformed? Could someone describe for me in words what the transformation here is based on what we did on Wednesday? How are we transforming it? Brendan? Right, so this is a horizontal shift to the right 4 units. Okay, which means we're going to subtract 4 from all of our original x values. Okay, all right, so remember, we're underneath the square root symbol. Whenever you're working inside the function, you're doing a horizontal shift, and horizontal shifts are counterintuitive. When you see subtract 4, you go to the right. Okay. So when you do transformations, you have a couple of, and it really depends on how you operate. Some people like to think purely visually with the graph. Some people like to work with tables. So I'm going to show you 2 approaches today again. So what I would do is my original function was g of x. So I might make a little table of nice, easy values for g, like if x is 0, the square root of 0 is 0. If x is 1, the square root of 1 is 1. If x is 4, the square root of x is 2. If x is, what's the next one after 4? 9, that's nice and easy, 16, and 4. So my original points on my parent function g would look like this, and that's what's graphed above. Okay. So what did our transformation say? We're going to shift everything to the right. We're going to make them 4 greater. We're going to subtract 4 from the x values. Now, nobody said anything to me when I did that. You just allowed me to write it. Is that what I'm going to do if I'm going to shift it to the right? I'm going to subtract 4? No. I was hoping someone would yell at me, but nobody did. Right. When we shift to the right, what we do to our original x values is we add 4 to the x values. So some people just like say, okay, here are my original x's. Now they're going to be, I'm going to add 4 to all of them. So now instead of 0, I'm going to be 4, and instead of 1, I'm going to be 5, and instead of 4, I'm going to be 8. So you add 4 to all my x values. Okay, so 13 and 20. And now you see what happens. When you put 4 into your new function, your transform function, your offspring, 4 take away 4 is 0, and the square root of 0 is 0. So it brings you right back to where you were originally. Okay, so now all you have to do is copy your y values. And now you have all of your new points to graph on your new transform function. Okay. So some people like doing it with a table and then graphing. Okay, so here's 5 points for you to graph. Okay, that's one approach. Some people like to go to their graph and mark some key points and just do it all visually that way. So it really depends on how you operate, how you learn better. So if you were to go to the graph, you would find some key points, and the same key points would be pretty much what I've put into my first table, 0, 0, 1, 1, 4, 2. So I'd go to my graph and I'd probably use a different color and I'd say, okay, 0, 0, here are some key points. Of course, you don't have to mark them all, just enough to get a sense of the shape of your transform graph. And 9, 3, that's as far as I'm going to go. And then I look at my transformation and it says, shift everything to the right 4 units. Nothing happens to your y. You just shift everything to your right. So this point 0, 0 just moves 4 units to the right. So let's mark that with a blue. So now my first point is 4, 0, because 4 take away 4 is 0, and the square root of 0 is 0. And then 1 moves 4 units to the right, and it's 5, 1. And 4 moves 4 units to the right, and it's 8, 2. And 9 moves 4 units to the right, and it's 13, 3. Okay? And then that's plenty of points for you to get a sense of how this graph, this transform graph, would work. Okay, so that's the kind of thing we worked on Wednesday in class. Okay, but I wanted to show you a couple of different ways that you could approach it. Again, sometimes people use both. They do both of them at the same time, or they get going with one way and then they just transfer to another way. There's really no like one set way of doing this. Okay, so let's compare the ranges and the domains of our transform function with our original function. Okay, so here's our original function. The domain, as Tiffany said, was from 0, including 0, out to infinity. What's the domain of our transform function? What's the domain of our transform function? Okay, so the domain of our transformation is, I heard 4, yeah? 4 infinity, right, okay. Has our range changed at all? No. When you do this horizontal transformation, you expect your domain to change, but not your range, okay? So that's the transformation. Why don't you try the next one, B, at your seats. Use whatever method makes sense to you. You can create some tables like I did real quick. Sometimes people just do tables with 3 columns and they skip this X, writing the X again, but it really is up to you how you do it. And we'll take a look at it together. I've taken a peek at just about everybody's paper and it seems like you're all doing this fine. How would we describe this transformation? How would we describe it? There's lots of different ways to describe it, so yeah. Go ahead. Right. Right. So what function are we shifting? What was the name of our function? Our original parent function. What was its name? G. G is the name of the function, yeah. So we would say the graph of G will be shifted, or has been shifted, whatever you want, whatever tense you want to use, will be shifted down 4 units, right? You could even throw in the word vertically there, vertically shifted down. You could also say, that means I'm going to subtract 4. I'm going to subtract 4 from which values? The y values, right. So I'm going to subtract 4 from all my y values. And that's the type of thing, when you say it, when you put it in those terms, it helps you do your little table here. Because you say, okay, here are my original points on my original function, right here. And I know I'm going to subtract 4 from all of my y values. So that helps you. So you can just write it right here. Here's your transformation. You can say subtract 4 from y values, right? And then you can create your new points. 0, -4, 1, -3, 4, -2, 9, -1, and 16, 0. And then you can go and plot them on your graph. So you've got 0, -4, you've got 1, -3, 4, -2, 9, -1, and then you've got 16, 0. And that's plenty of points for you to draw your new graph, your new transformation. Okay, there you go. All right. So anyway, any which way that gets you there. And the other thing would be to just find some key points on your graph, like we started out with earlier. 0, 0, and go down 4. 1, 1, and go down 4. Okay. So whatever floats your boat, basically. Okay. So let's take a look at our next one. Again, this is all review so far. This whole first part of the lecture is reviewing what we did the other day. Okay, so now we're still acting on the outside of our function. Our y values are going to change. It's going to be some kind of vertical change. And what's going to happen now when we multiply all of our y values by 2? What are we going to get? All the y values are going to double. And how do we describe that kind of transformation? Vertical stretch, right? So you're going to say, to describe this transformation, you're going to vertically stretch the graph of G, which is sitting right below, looking at you right here. Vertically stretch the graph of G. And here's where you can say by a factor of 2, by a multiplier of 2, whatever makes sense to you. If you don't like the fancy math language, you can just say multiplier. You can also say multiply. That means I'm going to multiply all my y values by 2. So I'm anchored at my x values, and I'm going to shoot up and become twice as tall as what this graph represents. You can do this with a table or with key points. Let's do it with key points again. 0, 0. When I double 0, it stays at 0. Here's another key point, 1, 1. So what's going to happen to my y value now? I'm going to become 1 what? 1, 2, right. So I double my y value, so I become 1, 2. All right, now where was I? What's another key point? 4, oops, try to keep the colors here on the original. 4, 2 was another point on my graph of G. So I'm going to double my y value only. I become 4, 4, 4, right. Okay, and now I go to the key point 9, 3 on my original function G. My x value stays the same, and I double my y value. I become 9, 6, right? And I think I still have 6 up here without my glasses. It's all right. That's plenty to show the shape of the transform graph. Okay. So you see, if you drew a vertical line straight down through 1, you see now how much taller or how much further away your vertical distances to the x-axis has doubled. Okay, that's what happens when you put a 2 on the outside of your function. Okay? Again, vertical stuff acts just like you think. Try the next one, which is a little more interesting, at your seats. Probably don't want. What's going on here? What are we doing to this? Yeah, Eric? It's a horizontal stretch, right? It works opposite of what we think. So the graph of G, our original graph, which is already right here, the graph of G has been horizontally stretched. Now, when you're stretching, your multiplier has to be a number bigger than 1. We're horizontally stretching, has been horizontally stretched by a multiplier or a factor of, and it's basically the reciprocal of this thing. 1 divided by a half is 2. So by a factor of 2. So that means that, what do I do here? How do my key points change? You double your x value. And if you look at this, you say, right, to get back to my original x value, I would have to double everything. My original x value here is 4. When I take the square root of 4, I get 2. To get back to this number 2, I'd have to double 4. Why? Because before I even act on it, before my act of square rooting, I got to take half of x. So x must be twice as big as it was, because half of 8 is 4. So my points, so my little, if I'm just working with points on a table, I have to multiply all x values by 2. So 0, 0 stays 0, 0. 1, 1 becomes 2, 1. 4, 2 becomes 8, 2. And 16, 4 becomes 32, 4. Well, I don't have enough space on my graph here to put that point in, but I can put 0, 0 in. So I'll put that as green and red. 2, 1. So you see, I'm right at the same height. See, here I am. Look, I'm at the same height, but now I'm 2. Because once I take half of 2, I get the square root of 1. And then 8, 2. And then that's good because I can't go out. So you just follow that shape, and there you go. All right. I know I missed it. What, the 9? Yeah, I just didn't feel like, okay. Thank you. All right, so the next 2 are just reflections. Do these on your own for homework. And now let's get into today's topic, which is a sequence of transformations. Some books call this multiple transformations. Multiple transformations. We're going to do more than one transformation on your original function. So, all right. A function involving more than one transformation can be graphed by performing transformations in the following order. Now, I'm going to put a little caveat with this. Your book, so here's what a transformation, here's all the transformations you could make on a function. According, oops, I got to change that letter. So it looks a little scary at first, but you'll get used to it in a second. So you can either act outside the function by multiplying it by a number. So I'm going to call that A. You can work inside the function. You can add things to the function inside. You can multiply things inside. And then you can go outside and add. So this is what it would look like in general if we put everything together. This is the way your book does it. Okay, and I want to make the point now, so if you go on to Math 108, your book does not pull out a common factor inside these parentheses. Whereas when you go to pre-calc and you do some transformation of trig functions, you're going to see this written a little differently. So this order goes with our book like this. And later on, you probably don't know what I'm talking about right now, but I will show you what this means later on our second example. So when you see more than one transformation, the first thing you're going to do with our book is horizontal shifts. Then you're going to do any kind of stretching or shrinking. Then you'll do a reflection if you see a negative sign somewhere, whether it goes over the x-axis or the y. And then the final thing you do is your vertical shifts. It's sort of like a little bit like order of operations, a little bit like that. Because look, the last thing you would do if this was an algebraic expression is to add d or subtract d. All right. Now, just because it bothers me to have any recipes for stuff. If this function looked like this, and again, you may not know the distinction, but if you just look for a second at the difference between these two things. See, now inside your innermost parentheses, I have the b multiplying x plus c versus saying bx plus c. In this format, which is more of what you'll see in pre-calc, you always do your stretches and shrinks first, and then your horizontal and verticals. And it won't matter, but it will come out to be the same as this, but it just depends on the original form of your function. So when we get to the last example today, I will show you how to do both of these and show you that they both come out to be the same. So for your purposes for homework and for your book, this is the order you're going to do it. And it's kind of nice the first time you do multiple transformations to feel like, okay, I have a little recipe to follow. So, all right, so here's our piecewise graph, which we worked with the other day. And so let's graph the original function k first. Okay, so it says on the interval, on the domain 0 to 3, we're going to be a horizontal constant function at 3. So there I am. Here's my first piece. From 0 to 3, y is 3. And then I'm a straight line with a -1 slope down to 6. I'm going to end at 6. So if I put a 6 in here for x, -6 plus 6 is 0. So I can mark that point and then just draw a straight line right down through. Okay. Now for some of you, you may want to just point out some key points here, whatever ones those might be. You might say I have 0, 3. I have 3, 3. I have 6, 0. Maybe one in between, 4, 2. Okay. Some of you, yeah, Megan? Uh-oh, I just pulled out my little, sorry. I just pulled this out of here. I won't be able to write anymore. Uh-oh. Anybody got fingers that are not as arthritic as mine that maybe could put this back in for me? Let me see. I think I got it. Okay. Sorry, Megan, go ahead. This here? Okay, so what this says is that k of x is equal to this straight line, -x plus 6. And the only x's that are allowed to go in there, Megan, are the x's between and including 3 and 6. So that means you could go like this to plot this. K of 3 is going to be -3 plus 6, which is exactly the same as this. You see, that's why it doesn't matter whether you put the equal sign up here or down here. Okay, so that's 3. So you plot that point. Then you say, okay, how about k of 4? What's that going to look like? -4 plus 6 is 2. That's this point right here. Then k of 5 is -5 plus 6, which is 1. And that's this point right here, 5, 1. And then k of 6 is where I stop because that's the end of my graph here. That's -6 plus 6, which is 0. Okay. So if you looked at this straight line right here, Megan, and you went from one point to the other, you'd go down one and to the right one. That's your -1 slope right here. Okay. Second slope started at 6. No, because this thing is only defined, Curtis, right here from all the numbers between 3 and 6. That's the only place that this is defined on that interval. It says plus 6. Well, let's put 3 in for x because that's your first x value, right? So if you put 3 in for x, okay? -3 plus 6 is 3. Okay. Any other questions on the piecewise before we move on? Okay, so here's our multiple transformation. Oh my God, you say, look at all this stuff going on. Where do I begin? Well, your book says do your horizontals shifts first. So you look inside your parentheses. Look, here's your function k. You're inside, you're going to add 1 to everything. So you add 1 to all of your x values. So how many, oops, I'm going to make another graph here just to make it a little easier for me. You can do it all on the same. I'm sorry you don't have, do you have 4 on yours or just 2? You have 2? Okay. But with working up here, it's a little more cumbersome. So let me just put another one. Oh, what happened? Ah, that happened. All right. I got to be careful what I click. I just got a really bad virus on my home computer. It's taken the guys downstairs 2 days trying to get it off and get it back to where it was. All right. Neither here or there. So we're going to shift everything. So literally, think about picking this up and just shifting it to the right, 1. So instead of 0, 3, what will your new point be? If you just move it to the right 1 unit. 1, 3, you're just going to add 1 to all your x values. So basically, 0, 3 will become 1, 3. What else you got there? You got 1, 3. That will become 2, 3. You got the point 2, 3. That's going to become 3, 3. You got the point 3, 3 hanging out there. That's going to transform to become 4, 3. Okay, and so on down the line. Every single point has 1 added to the x value. That's the first shift. So I'm just going to move this over. Instead of starting now at 0 for my domain, I'm going to start at 1. So I got 1, 2, 3, 4. The horizontal value 3. And instead of ending at 6, 0, I'm going to end at 7, 0. And then I'm just going to take the points like a little tic-tac-toe here, right on the 45-degree angle there. Okay. So that's my first shift right here. I have shifted to the right 1 unit. That's what this thing says to do. I've added, or you can say I've added 1 to all my x values. Okay. Okay, so I've done my horizontal shift. Look at your directions. What does it say to do next after you do your horizontal shifts? What's the next order in your recipe after you do your horizontal shifts? What's it say to do? Stretch or shrink. So you look inside here, there's nothing else going on. And then you look on the outside. And so now we're going to do a vertical shrink because we're outside our function. And we're shrinking because this is a fraction. When we'll deal with that negative sign in a minute. So we're going to vertically shrink all of our y values by 1/3. So that's the next thing I do. I'm going to do my vertical shrink. So here's my vertical shrink by a factor or a multiplier of 1/3. That means you take all your y values. So look, I'm going to just continue with this little thing I have here. Okay, so here was my first transformation. And now I'm going to take all of my y values. Okay, all of my y values, and I'm going to shrink them. Let me just put this on so we have this. Okay. I'm going to take all my y values and multiply them by 1/3. So what does everything along this horizontal line become for a y value? Instead of 1, 3, 2, 3, 3, 3, 4, 3, what will I become for my y value now? 1, because I take 3 and I multiply it by 1/3. So now my new points are going to be, all my x values stay the same. I'm going to be 1, 1, 2, 1, 3, 1, and 4, 1. So everything just gets shrunk down to 1/3 their size, 1/3 the height above the x-axis. So instead of being 3 above the x-axis, I'm now only 1. Okay. And then you say, okay, at 5, I was at 2. So now I become, oops, I made a little mistake here on this one. At 5, I was at 2. So now I'm going to be 2/3 of the way above the x-axis. So, oops, I'm about right there, 2/3. And at 6, I was at 1. Now I'm only going to be 1/3. Ooh, I can barely get it in there. And then 7, third of 0 is 0. So there's my shrink. Okay. Taking care of that. All right. Now what do I have to do? I have to reflect it over my x-axis. That's the negative. I have to reflect it over the x-axis. So that means all of these y values are going to become negative. So let's see, we got 2/3 here and we've got 7, 0. So now I got to need another whole color. I'm going to reflect everything. So the x values stay exactly the same and the y values just switch to their opposite. So I got 1, -1, 2, -1, 3, -1, 4, -1, 5, -2/3, and 7, 0. Okay, so now I just come down here and I go to -1, and then I just kind of walk my way back into 0. There we go. When you do multiple transformations, colors are really important. I'll take out my toolboxes in there which have like colored pencils. They're really great. Are we done? Are we done? Oh, more work. What do we got to do? Oh, finally, I think I've run out of colors. I'll have to pick purple here. Finally, whoops, that's not purple. How do I get purple? Come on, make me purple. I want to be purple. Will it be purple? No, I can't be purple. So what color do I need? Black. Let's try black. So finally, I have a 3 added outside to all my Y values. I have to add 3 to all my Y values, which means I do a vertical shift up 3 units. So I take every single one of these Y values and I add 3 to it. That's my final transformation. So 1, -1 becomes 1, 2. 2, -1 becomes 2, 2. 3, -1 becomes 3, 2. 4, -1 becomes 4, 2. 5, 2/3 becomes, add 3 to that. What do I get? 3 to -2/3. 2 1/3. Yeah. And then 7 becomes 7, 3. So 1, 2. So this point here goes up to 2. 2, 2 goes up to 2. 3, 2, 3, -1 goes up to 2. 4 goes up to 2. This goes up to 2 1/3. And then I end at 3. Is that right? Five, I'm not at 5, -1. I'm at 5, -2/3.
Yeah, that's what I got. 2/3 is above there.
Right, so what should this value here be? 5 what?
It should be.
Oh, I plotted it in the wrong spot. Okay. Yeah, I plotted it in the wrong spot. Where's my eraser? All right. All right. So let's see. I got to go back to my red and get this one in here. Okay. I'm sorry I can't because it's a big, I can come over and help you later, but I can't make this any bigger because, oops, hang on, let me just do what I'm doing. I want to get that little black spot out of there, but it's so big. Everything is so little here. All right, okay, let me just do this. We know these pens don't work all the time. There we go. Oh. Sometimes I make this look easy and sometimes it's just brutal on me. There we go. Okay, so this has got to go up to 2 1/3. So it's up here. So 5 goes to 2 1/3. It goes there. And 7 goes up to 3. So what is it that you want me to make bigger? Okay, so the only thing I can do is, no, I can do something. I can take a picture of it. I can do this. And I can cut it. And I can paste it. And I can make it as big as you need. Okay. So that's a little like, wow, baby, right? It's a lot of work. But if you take them one at a time, you can do it. Now, some people like having a brand new coordinate axis for every single time they do a transformation. Some people can do it all at once. I really like the point method myself. I do all my points and then I put the graph at the end. Okay, I graph them and then you can see everything that's happened. Here's your original graph. Here's your original graph, and then you moved everything over 1 unit to the right, and then you vertically shrunk everything, and then you've reflected, and now you've done a shift. So you can literally see all of your transformations that you've done. Okay. All right, I will come back to that, but I just want to, because I want you to have a lot of time to work on your own, I want to do the last one for you, and then I'll come back to this picture if you need me to come back. Okay. All right, so here's what I was trying to talk about earlier. Notice this graph has this form. Okay, has that form. Actually, I should use J because our original function here is called J. So let me just change that F to a J. Okay, so let's identify what A is. What's on the outside multiplying this whole thing? What would be the value of A? 1, right? So A is 1. We're not doing any kind of vertical stretches or shrinks, so that's out of the picture. No vertical stretches or shrinks. Now B is the coefficient of X. What's that going to be here? What's the value of B? 2. So that says 2x. To get back to my original X, all my X's have to be the opposite of what we think, half as small. So that's going to tell me I have a horizontal shrink by a multiplier of 1/2. What's the value of C inside here? 4. So that tells me I'm going to move to the, I'm going to shift to the right 4 units. And then finally, D is on the outside of the whole shebang. That tells me I go up, a vertical shift up 3 units. All right. So because it's in this format where the stuff inside the parentheses is not factored, you can see if I asked you to factor 2x minus 4, you'd say I have a common factor of 2. That's the difference. It's not factored. So when it's not factored, you do exactly what the book says. You do your horizontal, then you do your stretches and shrinks, your reflections if there's one, and then your verticals. So let's do this. All right, so the first thing I'm going to do, what is my parent function here again? X squared. So you all know what x squared looks like. It looks like this. Here's my parent function right here, 1, 1. I can do -1, 1, -2, 4. You can write a bunch of points for your parent function in if you want. You can actually draw your parent function in if it helps you. Just depends on what, you know, how you learn the best. So you can just quickly put in parabola. You all know what this parabola looks like. Symmetric about the y-axis. It's a happy parabola, right? You can put a couple of key points in. I would use even points here, and you'll see why in a minute, because I'm going to be taking half of everything. So I'm going to use my even points. Let's see, 0, 0. Let's throw a few in, 1, 1, 4, 2. Oops, excuse me, 2, 4, -2, 4. All right, so you got a couple of key points. You only need a few. So the first thing you're going to do is you're going to shift everything to the right. That's the first thing you're going to do. Shift this whole thing to the right. So 0, 0 becomes 4, 0. You're going to add 4 to all of your x values.
That's how you do the horizontal. Yeah.
What does it say? Horizontal shifts first, right?
Oh, you switched it.
No, I didn't switch it. I didn't pull out a factor. It looks just like this. Horizontal shift first. Okay, horizontal shift. So I move everything to the right 4. So 0, 0 becomes 4, 0. 1, 1 becomes 5, 1. -1, 1 becomes 3, 1. -2, 4 becomes 2, 4. 2, 4 becomes 6, 4. 3, 9, -3, 9 becomes 1, 9. 3, 9 becomes 7, 9. So I've done my horizontal shift to the right. There I am. That's my first thing I do. So let's label some of our key points. I've got 0, 0. I've got 6, 4. I've got 2, 4. Okay. And I've got 5, 1. And I've got 3, 1. Okay, that's my first thing. Then I do any stretches. I only have, or shrinks. I have nothing happening vertically because there's a 1 outside of this whole function. So now I'm going to do a horizontal shrink. So that means all of my x values become half the size they were. So I take these points that I have here, and I take my x values and I divide it by 2, or I multiply by a half, however you want to think of it. So 4, 0 becomes 2, 0. 2, 4 becomes 1, 4. 3, 1, when I chop that in half, becomes 1.5, 1. My 0.5, when I chop 5 in half, it becomes 2.5, 1. 6, 4 becomes 3, 4. Okay, so I'm just going to now throw that in. There we go. And now what's the final thing I have to do? I have to move this whole thing up 3 units. That's my final thing I'm going to do. I'm going to move the whole thing up 3 units. All right, so just move it up 3. So your new point is now 2, 3. You got to do this yourself. I mean, there's just no way around it. 1, 4 becomes 4, 4. Excuse me, 1, 4 becomes 1, 7. 1, 7. You just keep doing them. Keep doing them and you're done. Okay. This is our final one right here, the one I shrunk. I'm going to take each one of these points and move them up 3. Okay, so 2, 0 becomes 2, 3. That's here. 2, 3. This point right here, 1, 4 becomes 1, 7. Okay. 3, 4 becomes 3, 7. And that's enough to get your shape, your final shape. That's all you have to do. You're not getting these exactly. You're just doing a stretch. I mean, a sketch. All right, so it's time for you to play. I will show you the other form later. I don't want to confuse you now when you pull out a common factor. I'll show you that on Monday. So you've got quite a few to practice now here. You've got 3 pages of them, okay? So you got to pick out your parent function, then you got to give the equation for your transformation, and then you have to describe it, okay? So you're not actually drawing these yet. We'll do a little bit of that on Monday. Right now, you're just trying to see if you can describe them and actually write the equations for the transformations. Okay, so you got about 15 minutes for that.